Hello everyone. The lecture in the series for A-level physics with the chapter physical units, quantities and units. I am Chinmoy and I am currently studying in UK for my MSc in Advanced Electronic and Electrical Engineering. I did my BSc back in Bangladesh, which is a country in South Asia. So I have been teaching physics for about 5 or 6 years right now and online only. And I'll be with you with all the chapters you need in your A-level physics. So let's get started without further ado. And previously on lecture 1, we studied about the quantities like vectors and scalars, and we studied about displacement overall, and we did some mathematical problems as well. So we'll be continuing that, and in this lecture we'll dive into more into the realm of vectors. What are vectors? And we know what are vectors from lecture 1, but how are they interacting with each other? What are the quantitical things? What are the formulations of, and etc. about these things? Okay, so let's get into it. So first of all, let us just remind ourselves about the addition and subtractions of scalar quantities. Those are very easy. Those you have been doing for years right now. Let's say my mass or anything else like your money, your mass, anything that's a scalar quantity. Let's say that's this is your mass is like 55 kgs, okay, and you are in a lift. Let's say you are in a lift with many people, like a lot of people. You are in a lift, and the lift in the lift you get a lot of more people. Like there is someone with, let's say, 100 kgs of weight, he is overweight. Someone with, let's say, a child with 25 kgs of weight. Now for the lift in the system, inside the system, if I say what's the total weight, overall weight, you will just say me the total weight is 55 kgs plus 100 kgs and 25 kgs, right? And it will calculate to 180 kgs. So how did you do it? You just added them, right? This is called scalar addition. In this addition, you have to just add the values, nothing else. You just added 55 plus 100 and 25, and that gives you 180 kgs. As easy as that. You have been doing that for years. And one thing to check is that the units do not actually change here, right? So the total units, see, the kg, kg and kg brings you something in kg only. So units do not change. You can't expect, like if you just add 1 meter per second, let's say you are adding 1 meter per second with 2 Newton. You can expect it to be 1 plus 2 means 3 meter per second, not 3 Newton as well. This is wrong, right? This can't be happening. So this is truly wrong. You can add that. So you have to just look to the units. You can actually add or subtract same types of things. You can add meter per second with meter per second. You can add it Newton with Newton. Okay? Right? So you can add kgs with kgs only. Right? You cannot add kg with anything else. Right? So units do not change while adding or subtracting as well. Let's say it is a box full of apples. These are the apples. Okay? These are the apples. So there are, let's say, 100 kgs of apple. What you did is take some apple away. Like you take away like 20 kgs of apple. Taken away. So how many will be there? very simple, 80 kgs, right? So this is subtraction, and also the units won't change. This is very easy. Okay, and they are done in mathematical addition or subtractional way. So there is no geometry or other thing involved within it. Now, if we multiply or divide scalar quantities, that's how the fun starts. See, if you multiply kg, let's say 2 kg into 4 meter per second, you will get 8 kg meter per second. See, the units do change. The unit was kg, for one it was kg and another it was meter per second, but the units for the answer is kg meter per second. So units change while multiplication. Multiply also division as well. Let's see, if you divide 100 Newton by 2 meter square, you will get 50 Newton per meter square, right? So multiplying or dividing scalar quantities will actually bring change in the unit. Of course it will bring change, but addition and subtraction will not. Now let's study about vectors more. So we are studying vector in one dimension. What does dimension mean? Dimension means the pathway of something happening. See, our world is three-dimensional. What I am saying is our world is three-dimensional. Everything you look out for yourself within the environment and everything in front of us, in back of us, everything is three-dimensional. How is it? Let's say you are in a room, okay? You are in a room in your house, and the room actually has three dimensions. Ever noticed it? There are three dimensions, like there's a length associated with it, there is a width, and there is a height of the room, right? So if we apply some mathematics on it, like if we say this dimension is x, this dimension is y, or this one is y, this one is z, assuming. So the length lies in the x dimension, that's one dimension. The width lies in the y dimension, that's another one dimension. And the height lies in the z direction, that's another dimension. So everything is 3D. You are like there is a table, on the table there are books, the books are also 3D, the table is also 3D, everything is 3D, okay? Everything is 3D. So you can associate all these things here. Now we are studying right now is one dimension. So either we are studying about x dimension or y dimension or z dimension. For simplification, let's study about the x dimensional thing. So we will be studying right now about a vector in one dimension. This is x. Now in the previous lecture I have told you about what are vectors. Like vectors have both value and a direction. Vectors have both value and a direction. So this is a dimension. This one, this is not a vector, this is a dimension. Now let's say there is a vector called F, which is a force vector, and let's say this is 20 Newton. So we can just say this 20 Newton is in x dimension or one dimension, x direction, Okay, direction towards the x-axis. Now, let's say another force, let's say this is 40 Newton. Okay, this is also in the same direction, right? This is parallel to it. This is also in the same direction. So this is one dimension as well. Let's say another vector. Let's say another vector. This is like, what can you say, like 45 Newton. This is in the opposite direction, but this is in the same dimension. See, the direction is opposite. Direction is opposite. Direction is opposite, but the dimension is same. Okay, one dimensional, everything. Now another part, another fun part about vectors. See, the value of the vectors depend on the length of the diagram. Another, I'm telling it another time. The value of the vector depends on the length of the diagram. See, how much is it? I'm saying this is 20 Newton, right? That's why this 20 Newton is half of the 40 Newton. It has to be. On the flip side, the 40 Newton is multiplied by twice to be from 20 Newton to twice 40 Newton. So this is twice the length. And 45 Newton, see this length is better greater than this one, 40. Of course it will be greater. Okay, so there are some things you will be knowing in the upcoming sessions. So don't worry about this, just keep it in mind. Okay, so we'll be studying vectors in one dimension right now. Now, parallel and anti-parallel vectors. So the name suggests it. What are parallel and what are anti-parallel? Let's say one vector is a vector. Okay, this is on this line. See, I'm drawing a line. This is on this line. Okay. Now another vector. Let's say this is vector B. You can from the figure easily say that these are parallel, right? In parallel lines, parallel holding lines, the vectors are. So what happens here is that this is on parallel line. Okay. Okay, just wait 1 minute. It will slightly, yeah. And now it will be on parallel lines. Okay. Let's do another vector. On the parallel line, but in the opposite direction. Let's see. Let's assume C vector here. Now, from the figure itself, you can tell everything. Like A and B are parallel vectors. Parallel, right? But B and C, those are parallel as well on the parallel line, but on the opposite direction. B is heading this way, C is heading this way. So this is anti-parallel. Okay, anti-parallel vectors. And another thing, A and C, those are parallel as well, but they are anti-parallel. So what are parallel anti-parallel vectors? Those who have the same direction, same to same direction, are parallel vectors. And whose are on anti-parallel? Those are on the opposite directions or anti-parallel. So why are they applied in real life? Let's see. Let's see. Assume this is a block of mass and there are two forces acting on it. This is one force and this is another force. Okay. Let's say this is 25 Newton and this is 20 Newton. So these two are parallel vectors. Okay. These two are parallel vectors. Parallel. Now one more thing. Let's think about one more, what should I say, example or case where 25 Newton and 20 Newtons are in the opposite direction. So these are parallel but on the opposite direction. That's why this is a case for antiparallel vectors. Okay. So this was the basic of it. Now we must understand what happens if we impose same kind of vectors parallelly or antiparallelly on a mass or something, like on a point. See, this is Newton and this is Newton as well. So these are two vectors of force vectors, right? And they are acting on a same mass, and right here as well acting on a same mass. So we must know the effect. We must know the real life effect of these things. So here comes our next topic, resultant or addition of vectors. So right now we have to start worrying about how do the vectors sum up. Resultant means the summation. Okay, like we summed up kgs with kgs, like this is, say this is 5 kgs, another block is like on top 2 kgs, so total is 7 kg, right? This is the summation of a scalar quantity. But for vectors, they have direction associated with it, so the summation will also have a direction. Or on the other hand, we can say if we add vector 1 plus vector 2 and get another vector, that is called resultant. Okay, this is called resultant. Now we must understand the process of it. That's very simple actually, not anything like over the moon. This is a very simple mathematics it will be. Now for vectors we must give them an arrow over it, so specify that they are vectors. Okay, so vector 1 plus vector 2 means another vector. So let's say vector P and vector Q sums up to vector R. So we can say that R is the resultant of P and Q. Okay, R is the resultant of P and Q. This is in the equation form what we are saying, and this is in the written form. So which one is smarter? This one is smarter, right? It takes less amount of space, less amount of ink to write, and less amount of time. This is smarter. So this is mathematically and this is verbally. Now let's add two vectors. Okay, what I want right now is to focus on this type of two cases of scenarios, cases. Case 1, let's say this is case 1 and this is case 2, where on an object we are implying two forces, 4 Newton and 3 Newton. See, 4 Newton and 3 Newton. Okay, but there is a but. These two are different in the way that the directions of the forces, here these are parallel direction, but here this is anti-parallel direction, right? So this is parallel direction, parallel, and this is anti-parallel. Okay, parallel and anti-parallel directions. Now, if we ask you, many of you will tell me the right story. What will happen? See, on an object there are two forces, 4 and 3 parallelly, okay, on the same direction. So what will happen? What will happen is that this object which is here, let me just color it, it will look beautiful, and it will of course experience 7 Newton, right? 4 plus 3 is 7. Now from this one, the same object won't be experiencing 7 Newton, rather it will be experiencing, see, you are here, one friend of you pulls you in this direction, another friend of you pulls you in this direction. The right directional friend pulls you with 4 Newton, the left directional friend pulls you with 3 Newton. What will happen? It will be 4 minus 3, right? 1, easy peasy, right? So it will be 4 minus 3 or 1. Just think about it, 1 Newton. So these are the real life effects. Now what does physics do? Do physics say, okay, here is the rule, it will be 7, so you will experience 7, or physics works in the opposite way. Likewise, this is real life, this is 1, this is 2, and these two adds up to something, and physics identifies this is 7, right? This is what physics does. Physics doesn't impose any rule on nature. Physics, what does physics do? Physics just clarifies or explains what is happening in nature. So it will be done naturally. It will be done naturally. Physics will just explain the theory behind it, or the science behind it. What is the science? See, the science is that you can add up 4 plus 3, right? And it has added up to 7 Newton. What is the science here? You can subtract 3 from 4 and it will be 1 Newton. See, it's done. So how did we do it? So right now I'll tell you two theories. The first theory is for parallel vectors. If we impose two vectors, two same kind of vectors, Newton or Newton, same kind of vectors in the same direction, let's say this is F1 vector, this is F2 vectors, the resultant R will be F1 plus F2, and the value of the resultant will be F1 plus F2, right? See, there is a difference, subtle difference between these two equations. You have to understand it. This equation means that R is the resultant of F1 and F2 vectors. Let them be force vectors, or let them both be like acceleration vectors or velocity vectors, whatever it might be. But the resultant is R, and which is also the same unit, it has also the same unit. So this is telling that we will get a resultant, but what is the value of the resultant is just the summation. Now for this scenario we have two vectors as well. Let's say this is F1 on the right side, F2 on the left side. Now here comes the fun part. We'll get a R or resultant which is done by adding these two. See, this is still same for this case as well and this case as well. Don't think it will have a minus here. See, what you are telling yourself, or what you are telling to the nature, or nature is telling you that you will get a resultant. So you get resultant from F1 and F2. A resultant means what? Plus summation. So you'll get a summation. But how will you get the value? Now we'll get the value. This value is F1 or F2's difference. Difference means subtract the smaller one from the bigger one. subtract the smaller one from the bigger one. This is different. The difference. So this is the resultant's value. This is the resultant's value. But this is the equation which tells you that you will get a resultant. So don't get confused between these two. These two are the basic theories. This R and this R will give you the value of the resultants. You have done this, right? From this case, you have done just F1 plus F2. F1 plus F2, 7. And for this case, what have you done? You have just gotten the difference between these two. The difference between 4 and 3 is 1. And which will the resultant be? On the bigger side. The resultant will be on the bigger side. One friend pulls you from this direction, and friend pulls you from this direction. He pulls you by 4, he pulls you by 7. You go there in 1 Newton, right? You go in this way. Simple. So this is how resultants of two vectors are done. This is quite easy, and you won't be getting this type of questions, I think. This is very easy. What you will be getting in exams right now is what we will study. Resultant of perpendicular vectors. Perpendicular means vectors on 90-degree angle. Perpendicular to each other. See, let's say there are two vectors. Vector A and let's see, there is another vector B. Now, two vectors are perpendicular to each other. Okay? On a point, there are two vectors which are perpendicular to each other. How will you get the resultant? So for this one, I will be taking you into a journey on a map. Okay? Let's say you are starting from this point. You have already learned about displacement from the first lecture, right? So we'll be doing that. That was very easy. So this process is also easy. So from start point, you have a displacement like this one. Let me tell it S1 vector, as displacements are vector quantities. So from start, from A you go to B, and then from B you go to C. Okay? So you go to C, and this is the ending point. This is the ending point. End. Let me tell you, this is S2 vector. Now the fun part is, how will I tell you? This is displacement 1 vector, this is displacement 2 vectors. If I sum these two, S1 vector plus S2 vector, what I get is the total displacement. This is first displacement, this is second displacement. So I will get S, which is the total displacement. Okay? Now, what's the total displacement here? Remember, to find the total displacement, what you do is to just start a line from the starting point to the ending point. That's a straight line, nothing else. So a straight line from start to end. Just a straight line from start to end. And then this is your S vector. Okay, this is your S vector. Now look at a triangle here. What we got here is a triangle, right? And there is a 90-degree angle within. There is a 90-degree angle within it. See? So what's the fun here? Let's remember Pythagoras. What does he say? For the triangle ABC, it says that, see, this one AC square equal to AB square plus of BC square. The Pythagoras theorem. You have all studies in your childhood, right? It's very easy. So, what does AC mean? AC means the value of S, or we can say this is S square. This is S square. What does AB mean? AB means the value of S1, S1 square. What does BC mean? BC means the value of S2, S2 square. So, overall S is equal to root over S1 square plus S2 square. See? So, what we will do is to get this vector's values square and this vector's value square and add those two and get a root. You will get the ultimate, the resultant vector's value. So, coming back to this one, what can we say? We can say like this one, here S1 and S2 are perpendicular to each other. This one same, A and B are perpendicular to each other. So, just think about it. Someone pulls you from this side, someone pulls you from that side. Where will you go? Which side? You can't go either this side or this side. Not any of them. Where you will go is somewhere between these two. And believe it or not, it will have a triangle here. You will get a triangle here. Okay? This triangle, see this one. You will get a triangle here. This one is the triangle. And what are those values? See, if this is B, this is also B. This is also B. If this is A, this value is A. And this is, let's say this is R vector, the resultant. R vector means A plus B. This is the notation of the resultant, right? The notational equation. Now what we do is get the value of R and remember Pythagoras again. Pythagoras theorem. R square equal to A square plus B square, or R equal to root over A square plus B square. Okay, done. See, this is the theory. So, if two vectors are perpendicular to each other, then this is the resultant. Remember one more time, if two vectors are parallel to each other, the resultant is the straight summation, sum of values. Okay? If two vectors are anti-parallel to each other, the resultant is the difference between them. Subtract the smaller one from the bigger one. And if two vectors are perpendicular to each other, and this is root over one square plus another square. If you can't remember it, remember the Pythagoras theorem. You can remember it. So, let's dive into some mathematical portions. So, we'll get the what we'll right now do is get the summation of these two vectors. This is 3 Newton and this is 4 Newton. If you can't see it, I'll just, on an object there are two vectors, 3 Newton and that is 4 Newton. Okay. So, what will be the summation? So, the summation, let's say the summation is R. It is A square plus B square, right? Let's assume this is A, this is 3 square, and let's assume this is 4 square. So, root over 9 plus 16, root over 25, or R equal to root over 25 or 5 Newton. Done. As easy as that. We have already gotten the value. See? Easy peasy lemon squeezy. It's so easy. You have gotten the value. But now, there is something about vectors. You have to remember always that the vectors also come with a direction, not only value. The vectors must have a direction as well, not only value, because the value can be in any direction, like it can be 5 Newton in this direction, in this direction, in this. So you have to specify the value, the direction with the value as well. So here it is, let's say this is theta, okay. The value, the direction is theta with 3 Newton. Now how do we get that theta? So what we will do is just magic, mathematical magic or geometrical magic. So this is 4, if this is 4, this is 4 as well, and this is 3 is given here. So if we get the tangent, it will be 4 by 3, right? You all know the trigonometrical things, right? You all know it, tangent, sine, cosine, whatever. So the theta is tan inverse 4 by 3. Let me check in my calculator what's the value of it. Theta is tan inverse 4 by 3, 53.13 degree. You have to specify with which one, okay, to be perfect, because in the exam you need to be perfect to get the perfect marks. As easy as that. If you don't be perfect, your marks can be cut down, okay. So this will hurt you. So the theta is with the 3 Newton force. That's it. That's the perfect answer, and you'll get 100% marks for this one. Okay. See, this is very easy. Here, see, a spider runs along two sides of a table. This is taken from a book as well. Everything I'll demonstrate to you in the classes will be taken from a important book. Okay. So if you go through the lectures, you will also do important exercises from books. So you just need to study along with me. You just need to study along, nothing else you have to do. Just take the notes and study along. That's it, that will be enough. You don't need to worry about anything more. Just study along with me, and whatever you will get in the exam, it will be like you have seen this before in the classes. Okay, so a spider runs along two sides of a table, figure 1.13. So he runs along like this is east, this is north. So what he runs along is 0.8 and 1.2. Calculate its final displacement, and if you calculate it right like a noob, like what you do is just sum 0.8 and 1.2 and get 2, you will get a 0 in the marks because the displacement is from the start point to the end point, right? So what do we get? This is the start point and this is the ending point, right? End. So what's the displacement? The displacement is from the starting point to the ending point, from the start point to the end point. See, this is the displacement. So how do you get it? Remember Pythagoras again and it will be done. So the displacement, let us call it S. So the value of S equal to root over OA square plus AB square, or you could call S as OB, right? This is given. So whatever, no problem. So what is OA? 0.8. How much is AB? 1.2. Check it. What is it? From the calculator. Root over 0.8 square plus 1.2 square. 1.44. What's the unit? Unit is most important. See, in the previous examples we have gotten unit Newton because we added. What do we added? What did we add? We added forces. That's why we got Newton. Right now what we are adding? We are adding displacements. This is in meter, right? So you'll get meter. 1.44 meter is the value. So it says calculate. So also need to calculate the direction. Right now, check the question. They have already specified a theta here. So this theta and this theta is the same. See, mathematically, geometrically, these are the same values. So you have to get the theta here. So what's the theta? So tangent of theta equal to, see, if this is theta, so we will get 0.8 by 1.2. 0.8 by 1.2. Those who are finding it difficult to calculate theta, please check your geometrical formulas from your math book. Okay, please do it because you'll need it a lot in physics. Okay, this is a common thing in physics, so you need to check that. If you can't understand why is it 0.8 by 1.2, why not 1.2 by 1.2 by 0.2, do check. Okay, this is for your own goodness. Okay, please check the mathematical books. So theta equal to tan inverse 0.8 by 1.2, what is it? 33.7 degrees. So how do you specify it? See, this theta, this is east, this is north. So this theta is north of east, right? North of east. So we'll tell it north of east. From east it is in the northern direction. Okay? Or you can tell it a more smarter way. This is northeast, which is the northeast abbreviates to north of east. Okay, northeast. That's it. So it's done. Another math is done. Okay. 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 Very good question. Very good question this is. So we got 3 or more, 4 more maths. So we'll do that easily, and then we'll just complete our lecture or complete our topic. Okay. A river flows due north at 9 meter per second. A dog swims at 10.3 meter per second. Okay. Maybe this is let's take it out. 0.3 meter per second. Calculate the magnitude and the direction of the resultant velocity when the dog swims due north, due south, due east. So what we are thinking right now is about a river. Okay, so let's at first draw a river. Let's at first draw a river. Sorry, this is the river. Okay, this is the river, and in the river, what is flowing? The water, right? So the water is flowing to the which direction? See, due north means in the northern direction the water is flowing. So this is, see, this is north. So opposite side of it will be south. Okay. And where is east, where is west? Remember, if you face in the northern side, your right hand will be on the eastern side, your left hand will be on the western sides. Okay. If you, I'm telling you another time, if you head up towards the north side, your right hand will be on the eastern side, left hand will be on the southern side. If you don't remember this, just remember of your map of your country. Remember the map of your country, you will remember it. Okay, the maps are given in this direction. This is north, this is south, this is east, this is west. Okay, the maps are done in this direction. So if you stand towards north, the right hand side will be on east and the left hand side will be on west. So this is east, this is west. Now what about the question? What does it want us to do? It wants us to carry out the resultant velocity in 3 different scenarios. So let's say scenario 1. What if the dog goes due north? See, the velocity of the river is in river velocity. So let's say VR. River velocity is in this direction. Which one is it? This is 0.9 meter per second. 0.9 meter per second. Now the dog, which swims in the north direction as well. The dog also swims in the north direction. So the dog swims in this direction. So VD, D for dog, which is, how much is it? 0.3 meter per second. Okay. So what's the resultant? See, the resultant total V, if we say it as total V, what do? Add or subtract. See, these are parallel vectors, right? These are parallel. So I'll write it here. This is parallel vectors. So the resultant is just the summation. VD plus V river 0.3 plus 0.9. It is 1.2 meter per second. That's it. Done. Very easy. See. So number 1 is done. I know you'll get a lot of you will get this easily. I know, but let's do it together. Due south. So the river flows in the northern direction. V river is 0.9 meter per second. But right now the dog swims in the southern direction. The dog's velocity is 0.3 meter per second. As you can see, these are anti-parallel vectors, right? Anti-parallel. So for anti-parallel vectors, what do? You just get the difference. VD difference VR. What does difference means? Subtract the smaller one from the bigger one. Which is smaller? The dog's velocity is smaller. So subtracting 0.9, so subtracting 0.3 from 0.9. So 0.9 minus 0.3, 0.6 meter per second. And which direction? This is due the bigger one. Which is the bigger one? Reverse velocity. So due north. So I forgot to add a due thing, due north as well. So you have to specify the, what did you need to specify? Magnitude and direction. Okay, both. See, this is given here. Now the fun part, due east. If the dog goes due east. So bear with me. This is reverse velocity. How much is it? 0.9 meter per second. Okay. Where does the dog go right now? Dog goes towards the east. Okay, I think I made a mistake here, right? From the northern direction, from the right hand side, it will be, which one? Yeah, I made a mistake. This is eastern, this is east, and this is west. Okay, this is west. So you need to change all that. Okay, I just remove this one because we didn't need east and west in the first two parts. So I'll just remove this to clarify the mistake. So in the eastern direction, where does the eastern direction? Eastern direction is this way. In the eastern direction, the dog swims VD, which is 0.3 meter per second. So I'll take everything here. Just give me a moment. I just made a terrible mistake here. shouldn't have done it. However it is. Let's follow it up. Meter per second. Okay. Now, what is the resultant? These are perpendicular vectors. Perpendicular. See, perpendicular vectors. So, the resultant will be on this direction. Okay. So, this is V. So, how much is the V? V is root over Pythagoras theorem, right? V reverse square plus V dot square. Root over 0.9 square plus 0.3 square. And how much is it? .95 meter per second. This is the velocity, the value of it, but what about the direction? You have to get the direction as well. So let's see, let's check. This is theta. So if this is theta, tangent of theta will be equal to this one by this one. This one equals this one, or the velocity of dog. This one, this is 0.3, and the rest is the velocity of the river, 0.9. So tan inverse 1 by 3. .43 degree. Okay, you have to specify the directional thing. It is due north, but due north, due this side. So due east of north. East of north, or you can say EN, which is simply saying east of north. Okay. And what will I do? I'll give it as the homework for you to do, because this is pretty easy. An aircraft is flying due north, and the side wind is like troubling the aircraft with a velocity. This is actually practical. Practically this happens, okay? Practically this happens, and the aircraft's engine or the mechanisms within it will have to adjust to go with the directed direction. See, we all have a application right now. Have you ever wondered while the aircrafts to land on airport, they don't always just head in the runway, right? See, this aircraft is heading this way, not in the runway direction. How do you think? The aircraft will just have an accident? No, they do it purposely. They do it on purpose. Why? Why do they do it on purpose? Because there is a science behind it. They have to land this way, on this direction, to safely land on their runway. If they don't, they will just have an accident. But how? Let's see that. Let's assume this is the runway, okay? This is the runway, okay? Now, wind is going see, wind is going this way, okay? Wind is flowing in this way. This is the velocity of wind. Now, if the wind flows in this way, if the aircraft comes in straight this way, so let's just try to, okay, assume this is an aircraft, okay, don't judge me on that. So the aircraft is coming in, velocity of the aircraft is this way, but if the wind is this way, then what will it do? it won't follow this path. The wind will take it to this way. And if the aircraft goes this way, it will have an accident. So this is accidental case. To go through the runway, the aircraft must do one thing. What does the aircraft need to do here? See, this is wind. Okay, this is wind. So the aircraft must head in this direction. They must head it to this direction. So this is aircraft's velocity. It is heading in this way, okay? The aircraft is heading this way. Now the aircraft, if the aircraft heads this way is the wind, the total resultant can be in this way. And what is this way? This way is the runway. Okay, runway. So this is example of a successful landing. Successful landing. So for a successful landing, the aircraft has to move in this way. Okay. See, this is what happening. The aircraft moving. So if you from now on ever see an aircraft heading to a different direction rather than the runway, you could easily see or say there is a wind within it. If it didn't have the wind, the aircraft would nicely go in this direction. But it has a wind, so it's going in this direction. And the wind is, where is the wind? See, wind is in this direction. Okay. So this is the direction of the wind. Aircraft is heading this way. This is the direction of the aircraft heading. Okay. Aircraft heading. So where will he go? He will just follow this path. Just go through this resultant. Okay. He will easily land. So the vectors or the resultant of vectors are so important that people's life or any technological advancement will depend on it. That's why you need to study this in this stage of your life. Okay. Now here is the last question, and this one can be a bit difficult for you guys, but we'll try it. We'll try every easy and difficult questions that might ever come in your exams. This is also in a book. What does it say? An aircraft flies 30 km due west and then 50 km due northeast 45 km. See, whenever they say northeast, you have to assume this is in the bisection of northeast. Bisection, you know what bisection is? The bisectional line which lies exactly between north and exactly means 45 degree. 45 degree due this, 45 degree due this is total 90 degrees. Okay, so the aircraft starts here. This is the start and aircraft ends here. Okay, this is the end. This is S1. How much is it? 30 kilometers. And how much is it? 50 kilometers. Okay, so we have to calculate what do we need to calculate? We need to calculate the total displacement. Let's say total displacement is this one. Yes. So you can't remember Pythagoras here, because for Pythagoras you need to have a 90 degree within the triangle. There is no 90 degree within the triangle. So what do you do now? Remember, for a triangle you can have Pythagoras, but also you can have other theories as well. You have to remember those from mathematics books. Okay, mathematics is very important for physics. Remember that mathematics is very important. If you can't do mathematics properly, you will actually struggle in physics. So I am not just frightening you, I am just telling you the truth. So you need to be a bit good in both. Okay. So be prepared for to be prepared for exams properly, because see, in the classes we covered, what do we cover? Or we covered like 90-degree perpendicular vectors, we covered parallel or anti-parallel. What if this comes? Because this is also in a book, and within the book there is no what should I say, no mention of other angles rather than perpendicular. For your A level physics, what do? You go back to the basics. We go back to the basic triangular formulas. Okay, see, we need this one. So remember, this is A, B, C. If you have A, B, C here, then there is a cosine formula which states that if this angle is C, of course, then we get cos of C equal to, remember this, AC square plus CB square. So at first we have to take the two sides of the triangle which is adjacent to C, these two sides, okay, and take the squares, minus you have to take the opposite side square minus. So for this angle C, the opposite side of the triangle is AB, minus AB square, divided by 2 AC into BC. Okay. So we need to, what do we need to get? We need to get this one, or AB. So next line you get AC square plus CB square minus AB square equal to 2 AC BC cos C. What do you need to get? AB. So AB square equal to AC square plus CB square or BC square minus 2 AC BC cos of C, or AB equal to root over AC square plus CB square minus 2 AC BC cosine of C. See, these are mathematics, nothing else. Mathematical calculations. So we got AB here. So right now back to here. If you want to get S, what do you need to do? Root over AC square plus BC square. So S1 square plus S2 square minus C minus 2AC. AC means S1. SBC means S2. Cosine of that angle. Which angle? See, not 45. You need to get that cosine of this angle, right? This here, let's say this is alpha. What is alpha? Alpha is 180 degrees minus 45 degrees. How? You know how, right? Don't you know how? You know how. This is total 180s. This is 45. So this is 180 minus 45. Let's do it. So root over S1 square. Okay. S1, which is S1, 30 square, 50 square, 50, right? 50, yeah. 2, 30, 50 cos x 180 minus 45. This is 135. Give it to a calculator. Let him do the rest. 2, 30, 50 cos 135. 74.31. This is kilometer, because everything is kilometer. See, this is kilometer, so it will be kilometer as well. Don't give a meter here, okay? That will be very much frustrating if you go everything right, just you get the unit wrong. It will be frustrating for you. Kilometer. And this is it. This is the answer. See how much is it? It is, if you know the mathematical reasoning behind it. So I'll urge you to remember this for this type of problem. So what we have covered today, this is the end of the class. What we have covered today? We have covered how to get the resultant or the summation of two vectors, whether they are parallel, whether they are anti-parallel, whether they are what? Perpendicular. And last but not the least, we have also covered an example from a book where it says it isn't perpendicular, it is in a different direction. So we have covered it as well. Okay. So here it is. Here it is. We are ready for any questions from this type of topics. So in the next class, covering more of the chapters. So till then, have a good good few days, and we'll meet you in the next lecture. Thank you. Bye.